Hello boys and girls, and welcome back. Today we're going to be studying the laws of exponents, going on and moving on from what we learned and inferred from class earlier. So laws of exponents and the date as our title. Our objective for today is I will be able to simplify expressions by using the laws of exponents. So our first rule is the product rule. So we have x to the a power times x to the b power. When we multiply them together, we can simplify it to equal x to the a plus b. So we multiply, we add. So during the product rule, we add. So x to the a power times x to the b power is equal to x a plus b power. So let's look at our example. We have h squared times h to the 6th power. So our h comes over, then we write 2 plus 6, and yes, I want you to write this down so you can refer back to it. I know you can do 2 plus 6 in your head, which is equal to h to the 8th power, but I want you to write it down in case you need to refer back to it or forget how to do it. And so our next example, we have negative 2a to the 2nd power b times 7a to the 3rd power b. Now remember, all of these spaces in between the constant and the variables are multiplications. So it's negative 2 times a squared times b. So just be aware of that. So what you're going to do first is multiply the consonants together. Or constants, not consonants, I'm sorry, constants. So we have negative 2 times 7. Negative 2 times 7, as we know, is negative 14. Next, we're going to look at the a's. We have a squared and a cubed. So let's write this out. We have a, and then we have to add. So we have 2 plus 3. And then let's look at our b's. We have b and times b. So b times b, we have b. And remember, b with no exponent on it is b to the 1st power. So when we have two just regular old b's, we have 1st power times b to the 1st power, so b to the 1 plus 1 power. So then, when we simplify all this down, we have 14a, 2 plus 3 is 5, and then times b, 1 plus 1 is 2. So our final answer is 14a to the 5th power, b to the 2nd power. The next rule that we're going to talk about is our power rule. So we have x to the a power all to the b power. So when we figure that out, it's x to the a to b, a times b power. Remember, when they're smushed together, there's a multiplication symbol in there. So x to the a times b power. Let's look at our example. So we have x to the 2nd power to the 3rd power. So we're going to multiply it, bring that over. So we have x squared times, there we go, times 3. Okay, so then we have x, and then 2 times 3 is 6. So x to the 6th power is our answer. Our next example is negative 2m to the 5th power, all to the 2nd power, times m to the 3rd power. So remember, this one we have to distribute. So we have 2 to the 2nd power squared, or negative 2 squared, and then we got to distribute to here. So we have negative, there we go, negative 2 to the 2nd power. Remember, that's negative 2 to the 2nd power, not the opposite of 2 to the 2nd power. And then times m, which is 5 times 2 power. And we got to bring this down even though we're not working with it yet. Okay, so what is negative 2 to the 2nd power, or negative 2 times negative 2? It is 4. So 4m, and then 5 times 2, 5 times 2 power, which is 10. And then we still have this last part of our equation, times m to the 3rd. Then we combine the last two terms using the product rule, so we have 4m, and then 10 plus 3. And then we get 4m to the 13th power. And that's our final answer. Our next rule is the quotient rule. Quotient means division, so when we're dividing with exponents, so we have x to the a divided by or over x to the b. So that equals x to the a minus b. So with division, we use subtraction in our exponents. So here are our examples. We have 27x to the 5th power divided by or all over 42. 42x. So the first thing that I like to do in these is to simplify the constants. So we have 27 over 42. So 27 divided by 3, I notice I can divide 27 by 3 and 42 by 3. So 27 divided by 3 is 9. 42 divided by 3 is 14. And then what we do with that is we're left with x to the 5th power over x. So we do x to the 5th power minus 1, because when there's nothing there, that means that there's a 1. So all of that equals 9/14 x to the 4th power. Now you see how I wrote that next to the 9/14, not underneath it, not underneath in the denominator. If you want to write it in the fraction, you have to make sure that it's in the numerator, because that would be a different answer if this was in the denominator. Okay, it's the same thing as me putting this over 1. All right, see how I did there? See what I did there? So either way, this way or this way is fine. You just have to make sure you're writing it correctly. If you have any questions over that, we'll do more examples and we'll talk about it in class. Our next one is y to the 2nd power over or divided by y to the 4th. And so there's our power rule. We got to multiply y to the 2nd times 2 all over or divided by y to the 4th. Okay, so y to the 2nd times 2 is y to the 4th divided by y to the 4th. And that equals, as you guys can see, that equals 1, right? Because y to the 4th over y to the 4th, that equals 1. We already know this. It's the same thing as me saying, well, what if y equaled 1? Well, 1 to the 4th is 1, so 1 over 1 is 1, right? So we have the numerator and the denominator are the same. That means it's 1. All right, the next one's the power of the power rule. Okay, so now it's kind of like what we were doing earlier with power of the product, power of the product. So kind of like what we were doing with the power rule, we have to like distribute that exponent. So we have x times y to the m power, and so now that gives us x to the m power times y to the m power. So let's see our example. We have 3a times 2 to the third, all to the 3rd power. So we had to distribute this 3 to the 3, to the a, and to the 2. So 3 to the 3rd power is equal to 9. 3 to a to the 3rd power times, and then 2, oh, I'm sorry, 3 to the 3rd power is not equal to 9, it equals 27. I was trying to do the 2nd power, equals 27, and then a to the 3rd power times 2 to the 3rd power, which is 8. Okay, so don't get confused. Let me just kind of scratch that out. That is 27. All right, the next example that we have is x squared times y to the 5th power, all of that over to the 7th power. So we need to distribute that 7. So x to the 2nd power times 7 times y to the 5th power times 7, and that equals x, and then 2 times 7, which is 14, so x to the 14th power times y, and then 5 times 7 is 35. So x to the 14th power times y to the 35th power. You know, it's kind of a big number, but that's how it is on this one. And the power of the quotient rule is the same thing, but it's with the division. So we have x divided by y, all to the m power, and then we have to distribute that exponent, so then it's x to the m power divided by or over y to the m power. So our first example, we have m over b to the second power. We need to distribute that 2, or the squared, so it's m squared divided by b squared. Simple as that. All right, our next one is 3x squared divided by 2y, so we got to distribute to everything x, or 3 to squared x squared, and then 2 squared y squared. So I know that looks kind of silly, so let's write it out. We have 3 squared x squared, and then all over, oopsie, there we go. And then we have y squared, or 2 squared y squared. So what is 3 squared? We know that's 9. X squared divided by, and then we know it's 4 y squared. And we'll just keep it, I know it's an improper fraction, we're going to keep it as an improper fraction because I'm more worried about the exponents right now. Our next one is our negative exponent rule. So our negative exponent rule is x to the negative a power is equal to 1 over, or 1 divided by x over a. So as you can see, that negative exponent becomes positive exponent when you switch it from the numerator to the denominator. Okay, so let's see an example. So we have negative 5x to the negative second power. And that equals 2. Now be careful with this one. That negative 5 needs to stay on top. It's still in the numerator because that has a positive exponent to it, right? Negative 5 to the first power, that's positive. So that needs to stay exactly where it's at. So then we have negative 5 and then x to the negative second power. That's what we're changing. So x to the second power is in the denominator. Okay, so negative 5 divided by x to the second power. And there we go, there's our answer. Okay, the next one is 4k to the second power divided by 8k to the fifth power. So once again, we're going to do the same thing. So this time we're going to be using the quotient rule that we learned earlier. So once again, I'm going to simplify 4/8 first, so we can see pretty easily that that is 1/2. And then we see that k, when we simplify this because of the quotient rule, we do k to the fifth power minus 2. So I like to look at it and say, well, 5 is bigger, so I'm going to do 5 minus 2. And then that equals 1/2 k to the third power. Now, you might ask me, well, why is this in the negative exponent example? Well, some of you might have just done, so we're on this step, we have 1/2, and then some of you might have said, well, 2 minus 5 is negative 3, so it would have been 1k to the negative third power. Okay, and now is exactly how it is up here. Now we have our negative exponent rule, and then we can simplify that to 1 over 2k to the third. Okay, so it's the same thing. It doesn't matter how you do it. This is just one less step, so that's how I like to solve it. Okay, and our last rule is going to be our zero exponent rule. So anything to the 0 power is equal to 1. Anything. So 7x to the 0 power. So we have 7 times x to the 0 power. So we have 7 times 1, because x to the 0 power is 1. 7 times 1 is 7. So our answer for this one is 7. And then we have w to the 4th to the 2nd power, and w to the 8th power. So then we have w, and then remember this power rule, 4 times 2 over w to the 8th. That stays the same. We're not doing anything with that yet. 4 times 2 is 8, so we have w to the 8th power over w to the 8th power. Now, some of you might just see that that's 1, but let me show you why it's 1, because when we have w to the 8th minus 8th power, there's our quotient rule again. That equals w to the 0 power, which is equal to 1. All right, so please don't forget your questions at the end.